Hello, I'm Robert Sandefur, lead developer and director here at Harmonic Software Production Studios. Today I'm going to talk about how to do multi-stack migration using FileMaker Pro without the use of migration imports or scripting. As FileMaker developers, data migration for the sake of system upgrades has been a long time challenge. It either involves time-consuming import cutover scripting or manual cutover importing. File separation can be helpful, but only to some degree. In many cases, changes go deeper than just a UI file swap out. Alternatively, some of us have just chosen to live develop and hotfix our customers' production systems. For our smaller customers, they don't mind this because they can get their stuff done much faster, but it does pose problems. As many of us know, when we try to commit the schema and users have records locked, sometimes we are unable to commit that schema and we have to wait. And the chances that this individual have just stepped out to lunch are pretty good. When we do get the schema committed, it shakes the system. Our tabs flip back, our sliders flip back, people get coffee cups, and our users instantly lose focus. And let's not forget about simple developer mistakes, because all live fixes are inherently untested. For at least one of our clients, we are no longer allowed to develop in the production system. This is a multi-decade long habit that many of us have had to break, and it has not been easy. The customer demands that features and changes be reviewed and tested before they are put live, and that developers do not disrupt daily work with system changes. If we are developing as we should be, then we are not working in the live copy. The simple end game here is just to take our new developed file and take our live data and stick it in there. So thank you, Claris, for the FileMaker data migration tool, because that makes that all possible. For our process here at Harmonic, there are 6 primary elements of the FileMaker multi-stack development build process: customer involvement, the multi-stack system, version control system, scheduling and naming, the migration itself, and then post-migration processes. And then after that, I'm going to discuss a few of the challenges that we have found and how we've dealt with some of those. The first element, customer involvement. This is absolutely necessary. Ideally, your customer will appoint an individual who can be a liaison between you and the users, or an internal system administrator. The individual would be the one who receives the reports of issues, feature requests, and all things database related. They would be the one to correspond with you, test, and approve changes. The second element is the multi-stack system setup, and you need at least a 2-stack arrangement. Ideally, each stack would be able to mimic the production system. The production stack being, of course, the customer's live running system. This is where we are no longer allowed to hang out. The staging stack is ultimately where approved for build would be staged. These files will eventually become your new production system. The development stack is where initial development and conceptual work would be done. With a 3-stack system, customers would ultimately approve the changes in the development system, and those changes would then be moved into the staging system. With a 2-stack system, staging and development are basically the same thing. This can pose some challenges, though, because it is very easy for unfinished work to go live. Currently, with at least one of our customers, we are successfully pulling off this process with a very large multi-file system using the 2-stack model. And while we do not have any actual development stacks, we do have 2 test servers where we are able to do conceptual work, mock migrations, and test elaborate changes. The next element is the version controller ticketing system. A good ticket system is going to allow you to track all of the changes that are slated to go into the production system. At Harmonic, we use Mantis. Mantis lets us assign versions to the tickets. It also lets us track conversation, changes, and notes about the ticket's issues. And it lets us interact with the customer for use case, expectation, user input, and ultimately their approval. Inherently, Mantis does not let us track assets, but we do use some of the header level fields to track the assets that are affected by the ticket. The assets are the files or components that are being changed or worked on in that ticket. If you have a single file system, that is your only asset. If you have a multi-file system, not all files may be affected by the current build and may not need to be included. External system resources such as ESS, PHP, these may also be affected by your build and would require cutover work. It is important to keep track of all of the files and assets affected because there's no reason to do more work than you need to do. There's no reason to move everything if not everything is changing, but yet you also don't want to forget about that one obscure change in that one field, that one table, and that one file. As a side note, we also use the ticketing system to create a ticket for the build itself. And in the end, this build ticket will get assigned back to the customer for their approval and sign off of the entire build itself. The next element is scheduling and naming. It is important to establish a timeline for your build for two main reasons. The first is that stale equals fail. Don't put it off. Too much time will cause complications. Do it in 2 weeks, set it for a month, whatever, do it and get it done. The next reason is because customers need time to approve the changes prior to the build. Developers need to finish their work in the staging or development stack, sign their tickets back to the customer for user acceptance testing approval. The customer needs to have time to get all this done before the build. This can occur the same day as the build, but that's a little too close for comfort. Naming is important because you need to be able to distinguish one build from another. Just like our operating systems, we know the difference between one Windows version or another, or one Mac version or another. So for the same reasons, we need to know the difference between one build and the next. So give your build a name, give it a number. Here at Harmonic, we give our builds at least a number, and in some cases a creative name that's usually named after somebody's favorite food. Plan your next version immediately. Date and name TBD if necessary, because unfinished work that is not going into this build may be going into the next. So that next build at least needs to be identified. Beyond that, create a catch-all for all tickets that do not yet have a build to go into yet. Once all tickets are assigned to the build and everything has been approved or moved, we are now ready for the migration. So this brings us to our next primary element, that is the migration itself. This is where it all comes together, but it is also at this point that one mistake could be huge. If you get your backups mixed up, if you get your production and staging files mixed up, just be careful. We do not migrate on our original files. We run backups and we migrate on those. Every step along the way, leave yourself backups. Leave yourself a fail-safe in case the next step fails. Where should you migrate? Well, you can technically migrate anywhere you want, but the things to consider are speed and capacity. Capacity is a huge consideration because you do not want to fill up your drives. Especially not your FileMaker server drives. My rule of thumb for needed free space is the total size of the original files in your migration times 4. Times 4 being, first is your original files, the second would be your newly migrated files, the third being the scratch space that the migration tool needs to do the migration, and then the fourth being that you do not want to max out your drives in that process. So if you have 4 times the amount of space of your original files, you should be good to go. So from the production server, we kick off any remaining users and run backups of the files that will be used in the migration. Then unhost them, but leave them in the FileMaker folder. If there's a UI file or a main entry file, we close that as well because that prevents users from entering the system and altering data during the migration. In the staging server, we also run backups of the same files using the clone option in the backup schedule. This is a huge time saver. Our migration location is usually on a separate test server. We create a build folder, and in that folder is 3 folders: the data folder, clone folder, and the new folder. Production backups are placed in the data folder. Staging clones are placed in the clone folder. Then the build folder is transferred to the migration location. From here, the FileMaker data migration tool will be used to migrate each file. For those of you that are not familiar with the FileMaker data migration tool, this is what makes it all possible. It is a command line tool that lets you specify the data file, clone file, and output path, credentials, and a handful of settings, then takes the data from the specified data file and migrates it into the clone and saves it to the location you specified. The command can be very long and cumbersome to generate. Not a big deal for 1 or 2 files, but try 30. In my demo, I'm migrating 9 files. At Harmonic, we use a file nicknamed Midge. Midge is a FileMaker Pro database that simplifies the process for our multi-file systems. Midge stores the folder paths that you've specified and the credentials and settings, and then it reads in any of the FileMaker files listed in those folders. The settings and paths are stored at a session record, and the file names are stored in child records to that session. Midge generates and runs the command for you. The command is modified to redirect the output to a log file that is named and located the same as your newly migrated file. Progress is determined by the size of the new file compared to the size of the original file. Success and completion are determined by reading the final summary section of the log file. By redirecting the command line output to the log file, we are able to allow FileMaker to just execute the command and let go. FileMaker does not have to wait for the command to complete. FileMaker can read the log files and the size of the new files to determine progress and completion. This also means that you can run more than one migration at one time. A couple of precautions though: server-side schedules, scripting, and backups. Before you migrate, you may want to consider disabling these. If not all the files are closed, then some server-side scripts may run poorly and yield bad results. If your backup schedules tend to run long, you may want to disable those as well. When it comes time to move your files back to the production server, if backups are in process, you're going to have to wait. You're not going to be able to move those files till your backups are done, and technically you've already run backups. All right, so that brings us to post-migration. Our migration is now complete. We now need to return these files back to the production server. As an additional fail-safe, we will take the files that are being replaced and copy them to a folder outside of the hosted folder and name it something like replaced by build, whatever. The newly migrated files are placed back into the hosting folder and rehosted by FileMaker server. Team communication is important at this point. Most of the migration process so far can be performed by one person, but once that is complete, each team member is going to need to verify their own work, make sure it is live and functional, and possibly perform backfills. So this discussion has mostly been about the build process and not so much about the stack development, but I do want to take a moment to briefly go over a part of that. If you're developing in one stack and your customer is doing their work in the live production stack, you need to be able to tell the difference. They need to be able to distinguish between the 2 or 3 stacks. You need to be able to tell the difference so that you don't accidentally find yourself developing in the production system. You need to know that you're in the staging system so you don't find yourself trying to research current data that's old. The customer needs to be able to tell the difference, or they could spend the whole day working in their development system. For one of our customers, reskinning is one of the steps in our migration process. One of our staff go into the staging file and apply themes that are not normal to make it clear that we are not in the production system. Then, after the migration, they go into the production system and put all the themes back to what the customer is used to seeing. This allows us to very easily visually tell the difference. The stacks themselves also need to be able to distinguish that they are the production stack or not. ESS connections, for example. It would be bad for your staging or development FileMaker stack to be hooked up to your production ESS stack. So naturally the connection criteria would be different. We use different login criteria in our dev and staging stacks than we do in our production stack, not only as a security measure, but as a safety precaution as well. Because if the FileMaker files fail to log in, then that's an indication we may be pointing at the wrong stack. Web and PHP connections may also have dev and staging versions and need to know to point to different root URLs. The point being, the stacks need to know who they are and be able to point to the correct places and visually inform the user. When the cutover occurs, you either need to go in and make these manual switches or you need to find ways to develop around them. Those are a couple of stories all to themselves. All right, migration verification. Two things for migration verification. Is my new work here? And is the customer's current data here? Go through the system and look for the new features, look for the new buttons. Go to the latest records and make sure that they are in fact the customer's latest data. At this point, we're not necessarily troubleshooting problems with new features. We're just looking to make sure that they are there to verify that the migration was successful. Any new tables or fields or calculation changes may need to be populated. If the table wasn't there in the production system, the data is not going to be there after the migration. New tables and fields are just simply going to be empty. Additionally, stored calculation changes may also need to be updated. Auto-enter fields who have had calculation changes will need to be updated as well. Now we should be just about set. Now we can test the new changes and features, and so can the customer. Ultimately, the customer will go to the build ticket and sign off on the build by resolving the ticket. Although, if there are issues, related tickets, including the build ticket, will remain open until the issues are resolved. Sometimes issues get moved to the next build if it can't be resolved in this build. Fixing issues at this point requires parallel work. So you must do the same work in the staging system that you're doing in the production system to fix any of these issues. Otherwise, if you don't put your changes back into the staging system, you will lose those changes on the next migration. Staging should stay in some form of lockdown at this point until the build has been signed off on. Be cautious how much work you actually put into the staging system until the build is deemed successful. Staging is now your new next version. Label it as such, schedule another cutover if you haven't already. Your staging and production systems should now be virtually identical with the exception of the age of data and any files not migrated. It's possible that you need to see more current data in your dev or staging stack. If no new work has been done in your new files, you could just swap them out for the production files. Although if work has been started, then you will lose that work if you swap your files out. In this case, we do what we call a reverse migration. This is where we follow basically the same migration process, but we rehost the files in staging. This gives us our current data in staging with our current work as well. And that's pretty much the end of the whole build process. So now at this point, we start it all over again. Some of the challenges, though, that we've encountered along the way, I've mentioned a few, but I'd like to restate some and add a few more here. Be aware of file links, your external data sources. If files are hosted on separate servers, or if files have had absolute paths entered, you could have some problems. Be aware of your file linking. If you've hosted a file in staging and that file is referenced by other files with an absolute path, when you move that file over to the production system, your files will still be looking to the staging system for it. So you need to adjust that path so it'll be a relative path to its own local server. ESS issues can range from connectivity and setting in credentials, some of which I mentioned a little bit previously. Field order can be a pesky issue. If two ESS fields are added into staging in a specific order, but then added to production in the reverse order, those fields will be swapped in your production system, and you will need to go in and correct those. The solution there is to have them removed from production and re-added to production in the same order that they were added into staging. So stack identity and end user access. I briefly talked about stack identity. What this boils down to is you're doing one of two things or something in between. You're either going into those files and manually changing the credentials and the paths, which can be problematic, or we are having to write functions and scripts that fork the logic to know the difference between the two stacks. Either way, it is problematic. One is manual work that can result in missed pieces or typos. The other are hard coding pieces into your systems that could eventually change. With systems the size of some of our customers, that could be a lot of hard-coded pieces to have to go in and hunt down and change if they were to move servers. That is also an entire other conversation of its own. You may also want to add some logic to your start script to warn non-developer or administrator users who enter the development or staging system that they may very well be in the wrong system. Meta record synchronization and the use of IDs and conditions. If you use IDs in your scripting and calculations, you may find that they don't always stay in sync. The trick here is to always create your records in all stacks in roughly the same time frame. This prevents other users from creating new records that are out of sync with yours. For example, one of our customers' systems has a role-based privileged subsystem that allows an administrator to control visibility of items in the system. The role system is based on the role ID. Therefore, some hide conditions or scripting may be looking for users who have a specific role ID. If all affected stacks are not in sync, these features could become confused and fail to work after the cutover. So, thank you for listening. I'm Robert Sandefur with Harmonic Software Production Studios.